it's not there. So wait a minute. Sorry. This week and next week we are going to introduce the TOSHA's CRA technical guide, and you should follow this guide to conduct your final term project as the only homework for this semester. Okay, so please pay attention to the class of today and the next week. Otherwise, you will unable to do the homework. Okay. So the course for these two lectures, we have two objectives. First, to understand what is TOSHA's occupational risk assessment technical guide, okay, and then what is the method for CRA, how to do it, okay. Its name is construction risk assessment, but actually in Taiwan nowadays is a risk management system. It does not only tell you how to do risk assessment for construction work, but also set up a regulation for you or specification for you how to perform or implement risk management system to identify the risk, evaluate the risk, then assess the level of the risk and control the risk. So it does not only talk about the assessment for the risk, but also the control of the risk. So actually this is a risk management system, okay? And it is not only applicable to construction safety, it's also applicable to environmental management and also project management. In project management, do you have course? I don't think you have course for project management. But for project management, when we talk about risk management for project delivery, deliverables, we also apply the same process for the same as the CRA. So if you learn how to implement CRA, you will learn how to do risk management for project management as well. Okay. So actually, this is quite useful techniques, and there are 5 parts for our lecture on this topic, and today we will only cover the first 2. We will talk about the background of CRA technical guide refinement, and then I'm going to give you a very brief introduction to the content of TOSHA's CRA technical guide. Okay, and next week we will talk about the other topic, and I will give you a demonstration of a real-world case, how to implement the CRA techniques on a real-world construction project, so that you can imitate how I perform in this case study as a model for you to do your final term project. Okay? Okay, so let's start the background of the CRA technical guide refinement. Okay, the concept of risk management or source management of construction safety has been proposed 20 years ago. Actually, more than 20 years ago. I would say 30 years ago, when I just came back from United States, I heard about design for safety. And in 2006, the requirement on occupational safety and health planning for the construction project are defined or regulated in the GPA 2006. That's about 20 years ago. And not until 2018, the TOSHA published the first version of CRA technical guide. So you see, this is not new thing, but the guide is very new compared with the idea of source risk management, source management for construction risk. Okay, And my material, my PowerPoint file is prepared based on the second revision. This is a major revision from the first one. And actually, they in the second revision, they want to reflect the refinement of ISO 31000. ISO 31000 is standards for risk management. So they want to reflect the modification on ISO 31000, 2018, and 3110, 2019. So they modify, the government modify the GPA Article 70-1 and also the standard contract template for public construction procurement. So after this, all public construction projects are required to implement CRA officially. Before that, they are encouraged to implement CRA in their project, but not required. But after 2018, it is required by law. Okay. So nowadays, when you go to the construction site and talking to anybody with the engineer or the site director, they must know CRA. This is required in all scale of project for in Taiwan, construction project for Taiwan. So, but in the second revision, the standard form was prepared for major project, like a project with 50 million NT dollars of contract price. So there is a objection by the project owner of a small project, like $1 million small project. So this year, February this year, they announced the third revision. And this, in this revision, they prepared the procedure for simplified procedure for small project with the contract price much lower than 50 million NT dollars. Okay, so that's the background for the revision. And in Taiwan, every phase in the construction project, according to the CRA, the TOSHA CRA, they have different guidelines to perform the CRA in different phases. Like in design phase, they have the design phase CRA for the designer, okay? And for the construction contractor, they have the guideline for pre-construction phase CRA for the contractors. And during the construction, this is before construction, this is during the construction. They also has a requirement on job site hazard identification and assessment before work execution. So in their construction plan, they have to also to conduct job site hazard identification. This is based on the construction safety and health facility regulation, Article 6, Item 1. Okay. And for the design change is when there is a change order issued by the project owner, then the CRA has to be implemented again for the part of change. Okay, for the part, the facility of the related to the design change, and also for operation and maintenance, there's also a guideline for CI before expansion, modification, and repairs, and also before operation and maintenance. Okay, so who have to do this assessment? Who are obligated to perform the CRA for operation and maintenance. Who? Designer or the contractor? Both of them. But the main roles to do O&M assessment is on the designer. Yeah, because the contractor is responsible mainly during the construction process. So after the structure has been built, the finish structure is related to the designer's idea. Okay, so the contractor is primarily responsible for the temporary facility, the safety for temporary facility, and the designer is responsible for the safety of the built structure, the finished structure. So generally, the designer is responsible for O&M risks. Okay. Okay, so let's move to the second part, the major part for the class of today, the construction risk assessment and management guideline. I told you. Okay, and the first one is to establish a risk management system, and there are some guidelines for establishing construction risk management system. The first one is the local occupational safety and health law. So all the project owner must adhere to relevant laws and regulations. The law mentioned here is GPA and the OSH Act. Okay. The second one, the purpose to establish this system is to support risk assessment and safety management. Okay, this local law is the first guideline to establish the risk management system. The second one is ISO 31000. Okay, the framework for ISO 31000. We will mention about the ISO framework later. And ISO 31000 provides a systematic approach for risk management, principle, structure, and implementation. The key principle here is to utilize data collected from external or internal sources for comprehensive, inclusive, and complete risk management, and apply a document-based modular approach. What is document-based modular approach? Is ISO approach. Do you know ISO approach? Okay, there are two approaches for management. ISO approach or project management approach. What is project management approach? We treat the project as unique. One project is unique compared with another one. So when you do project management, you plan for project management, you must analyze the characteristic of a project. So all project plan should be specialized. But for ISO means standard, right?
Yeah.
So everything is standardized. So we treat repetitive routine operation as ISO. Okay? So for ISO 31000, you do everything, you document. You document everything you do. Okay? Don't forget. Okay? You document everything you do, and you do everything you document. So you have to put everything you do on papers. So if you go to the job site, you will feel that everything must be documented. You have so many paperworks. That's because it's ISO based. Okay? Okay, another one is the implementation framework. Emphasize on leadership commitment. We mentioned about leadership commitment in this class, right? So the top management must commit So there must be a mission statement or a vision statement for the corporate. Okay, there's a leadership commitment and implementation. Secondly, a PDCA, continuous or cyclic process for execution, evaluation, improvement, integration, and environmental adaptation. Environmental adaptation implies that you have to adapt yourself or adjust your method according to the environmental condition. Okay, so we have mentioned, especially in your final project, you have to do site investigation to identify all conditions or factors that may influence or impact your workers' safety. Okay? And the implementation of projects including communication, consultation, scope definition, risk assessment, risk treatment, and monitoring, and documentation and reporting. Okay, so the last part is required. Okay, when you read a textbook on risk management, they won't mention this part. They only mention the first 4 parts. But in the ISO system, you must document everything you do and report them to the stakeholders or the project participants. Okay. So this is the ISO 31 framework principle. Okay, value creation, protection, sustainability means continuous improvement, comprehensive means inclusive, and consultation communication, governance, which means that there must be a system, a management system. Okay. And everything must be regulated. And the customization means you must customize your measures and according to the workers, the environment, the site condition, etc. Inclusive, you must include a cultural aspect and social aspect. And transparency. Nowadays, transparency is required. So you cannot hide anything. You cannot hide the potential risk. If you hide something you identify which is risky, then there will be a penalty. Okay, come with that. Dynamic nature, which means that the risk will change dynamically. So you have to assess it periodically. Okay. And the human and cultural factors, now we emphasize on this. The last part is also emphasized on ISO 31000, which means that you must use the best available information, including the external and internal sources. You must consult everybody which can provide information for you to do the best job on CRA. Implementation. And not only the information available, but also the uncertainty or limitation of the information. So you have to consider the available information and unavailable information as well. Okay? Okay, the structure, including leadership, commitment, design, implementation, evaluation, improvement, integration. We will talk about how to implement it later. And the process for ISO 31. First, communication and consultation. You will implement this in the first step for CIA, which is hazard identification. So you have to talk to people, including the workers, including the neighborhood, including your stakeholders, etc. And you have to define the scope, context, and criteria. Okay, we will talk more in detail later. And risk assessment. Risk assessment including 3 tasks. First, risk identification, then risk analysis, and risk evaluation. And then after risk assessment, you have to propose risk treatment strategy, and you have to monitor and review the risk response result, okay, and record everything, report it to the stakeholders, okay. Okay, then let's start the CRA process. The first thing in preparation of CRA is to organize your CRA team. Okay, how to organize the CRA team? The guideline. First, designer or construction personnel, which means the contractors, should establish a construction risk assessment team or task force. And then communication and consultation, they must maintain regular communication and consultation with both internal and external stakeholders. Who are the internal stakeholders? Who? Yeah, project owner, contractor, or workers, all label in the contractors and subcontractors as well, designer and PCM. So all project participants and all workers, including the suppliers and external supplier, not only internal. Sometimes the safety will be impacted by some external suppliers. So they all need to be consulted, okay? So the main purpose for CIA team is to provide insight of the construction risk assessment and construction safety management. And they are responsible to conduct risk assessment and risk management review, okay? So what are the main responsibility for CIA team? To provide insight and to do the review work, okay? Okay, so the scope for CIA. Although CIA can be implemented for not only construction safety, but in the TOSHA's CIA, they only focus on the construction task and worksite environment, okay? And they have to consider internal organizational condition whenever applicable. The content of CIA is to conduct work breakdown analysis. We will talk about the step by step, okay? And based on the construction plan, okay, we mentioned that many times. How about for the designer? Okay, construction plan is prepared by the contractor, right? Before construction work starts. How can a designer access to the construction plan? How? If they cannot access the construction plan, how can they do work breakdown analysis and do CIA based on it? How? The designer must simulate the construction plan. They have to imagine how the work will be performed on the job site. So after CI is implemented, the architect has to hire staff or engineer with construction experience after that. They do not only have the design experience, but also on job site experience. Know the details, the practical details of a construction work, okay? And clearly define the construction task or place environment details, okay? Because the construction plan will define the details of construction environment, okay? Oh, I mean, it should be hurry, okay? And define the scope of criteria for CIA. They have to follow internal and international and national standard. Now we follow CDM framework and comply with the laws, local laws, and the guidelines for construction work, and also use historic data, especially construction accident case report. And in this report, there will be an accident prevention measure proposed for the accident. Okay, then for preparation work, the site condition investigation and project engineering requirement analysis. This is the second step. After you organize the CIA team, you have to do site investigation. Okay, so the designer or contractor should conduct site condition investigation, performed engineering or functional requirement analysis. So it's called engineering requirement analysis. And the purpose is to use the result of site investigation and the engineering requirement analysis to help them to identify potential hazards. I will show you how to identify it later. Okay. And the key reference is this is key reference for them to develop the design and detailed design and the construction planning. Okay, this is the first form you have to prepare in your term project. It's the basic project information, including project title, site location, project site, project type, project overview, and project participants, including the owner, PCM, designer, supervision unit, and contractor, and also site condition, including this topography, geology, traffic, etc. Okay, all this must be investigated. Okay, and these are detailed information for the site conditions. You have to identify the potential hazard related to these site conditions and the hazard mitigation measures and the possible responsible personnel for that hazard, etc. Okay. And then you have to conduct the construction alternative selection based on the hazard identified. And the alternative selection guideline should include items such as technology, functionality, cost, safety, schedule, etc. To select the best alternative for the work. Okay. And they should also identify potential hazard associated with the selected alternative. After you select the alternative means construction method you select. Okay. For example, for the foundation construction, you have many choices, right? You have a single pile foundation. You can have a mass foundation. You can also have curtain the diagram foundation. Many different type of foundation. So when you decided to choose one alternative, there will have a potential hazard come with that. Okay, and you have to provide a table look like this. You have alternative A, B, C, and you have to consider the function for the alternative, the technology, complexity, and the cost, project duration, site condition, safety, etc. Okay. And finally, based on this evaluation, you can choose the best alternative. Okay. So that's alternative selection. And then you will come to the core part for hardcore for the CIA assessment, which is construction plan and work breakdown. In CIA, associate CIA, we have to do work breakdown structure. Have you done work breakdown structure? So yes. No. Actually, it's a process to break down a project into small components and go on until you can use the component to survey or to evaluate the risk. Okay, so usually we break it down into 4 levels. We break down project into sub-projects, and then sub-project to first level item like work package, and then to the second level we call it activity. We use activity for scheduling if you learn how to do schedule planning. And after activity, we still have to further break it down into operation. Operation means activity with small steps. And this step will involve construction method or process or tools and equipment used or safety facility or measure are being adopted in this operation and management requirement for this operation, and also for protective devices like PPE for the workers. So in the CIA, the work breakdown structure is even more detailed compared with construction planning. So in construction planning, we only break the project down into the activity level so that we can estimate the duration for the activity, right? But for risk assessment, we have to further break it down into operation level. I will show you how to break it down. This is how we break down a project. This is the project. We break down into different parts of the project, like different building, okay, or different like landscape work. This is structural work, the foundation work, structural work, MEP work, and then landscape, something like that. And then for the foundation, we also have the excavation. We have the foundation structure. We have the formwork or something like that. This is activity level. But for risk assessment, you have to further break down. For example, for formwork, you have one formwork assembly and formwork dismantle. A formwork assembly operation is different from assembly dismantle. For formwork operation, you have to lift formwork from ground level to the higher top level of the building. And this is operation. And this is associated with lifting equipment, right? So you have equipment, you have management requirement, you have the tools to use, and you also have protective devices or protective equipment. So that's how we break down the construction work. And in the 10th project, I require you to take a component of the project, like a sub-project. Or actually, you can select an activity, like the foundation part, and you further break it down into operation level so that you can consider all the associated information with this operation and identify potential risk with this operation. Okay? Okay. And we can also prepare the work breakdown structure like this way. Okay, this is more common because this is not common because it's difficult to document on a paper. but this one is much better because it's tabular. Okay, so you can use this format to break down your project. Okay, then we come to risk assessment. The guideline for risk assessment, the step including 3 steps. First, risk identification. Second, risk analysis. Third, risk evaluation. The goal is to identify unacceptable risk so that we can proceed with appropriate risk management measure. So the purpose for risk assessment is to identify unacceptable risk, okay, through these 3 steps. Okay. So first, for risk identification. Risk identification should be based on engineering expertise and reference historical data to recognize potential hazard in work site environment and the construction task. And it is essential to analyze how this hazard may lead to risk. Remember the Heinrich's dominant theory. Here is dominant theory come to play in risk identification. You have to identify not only the hazard but also the source for the hazard, the cause to cause the hazard to become an accident, and the accident event, and finally, if this accident occurred, what are the potential consequences? Okay. Okay. Usually we use so-called 5M1E principle. What is the 5M1E principle? 5M means management, machine, method, material, and man. 1E means environment. And there are factors with each item of the 5E1M. Yeah, you have to ask yourself what method will be associated with this risk, what equipment will be used, what materials are involved, what men have to perform this work, and what management regulation or requirement are related. And finally, what environmental factors will affect or trigger the hazard. Okay, this is so-called 5M1E. There's a figure to apply 5M1E, a more immeasurable. Okay, where, what, why, how, and who. When a hazard occurs, what is the source of the hazard, which means what caused the hazard? Hazard related to unsafe behavior. What kind of unsafe behavior or unsafe condition? What type of unsafe condition will be related? And then, where will the hazard occur? Is in situ or out of sight? So where the source and when? When? And if you know the source and the where, so you can plan how to prevent this hazard. And what if the hazard become an accident? It will cause who to be a victim. Okay, so that you can prepare your hazard identification. Okay, and then to evaluate or analyze the hazard, including 2 items. The first is the probability of the event to occur, which is likelihood. And secondly is the severity of the consequence. usually we use a risk metric and calculate the risk priority number. And finally, based on likelihood and severity, we can determine the level of the risk. Okay, we use a likelihood scale like this. This is a 5-level likelihood, with 5 as the highest likelihood, almost certain to occur, and 1 means almost impossible. Okay, and you can use only 3 levels. 3 level only use 1, 2, 3. 3 stands for almost certain, and 1 stands for almost impossible. Okay, so this is the criteria for likelihood evaluation. How about severity? We also have 5-level severity and 3-level severity. Similarly, the number 5 means the highest severity, which means catastrophic, and 1 means neglect. Okay, and if you use 3 scale, 3 also means catastrophic, and 2 means moderate, and 1 means negligible. Okay, and with the severity and likelihood, we can come with the risk matrix. Okay, and this is the risk matrix with 5 levels. Okay, and we should take care of the top 3 levels: high, medium high, and medium. And we can ignore the low and medium low level risk for cost-effective consideration. Okay, and this is another risk matrix provided by Tosha. Okay, this is for 5-level risk. You can also use 4-level risk or 3-level risk. Okay, depends on the scale you choose for risk and severity evaluation. Okay, and usually we use 3-level risk, and for medium and high risk, you have to take action on mitigation of the risk, but you can ignore the low risk part. Okay, so how can you calculate the number here? This number is actually multiplied by the severity and the likelihood, like this one. If the likelihood is 3 and the severity is also 3, 3 by 3, you got 9, right? And for this one, 2 by 2, you got 4, right? And this 3 by 1, you got 3. Okay, so either you have very high likelihood or high severity, you can get a medium or high level of risk. Otherwise, you will get a low risk for a hazard. So for every risk event, you have to evaluate the likelihood of the event to occur and the severity for the consequence of the event for everyone, and calculate the number. This is called risk priority number. Okay, the higher number means it has a higher priority of the risk. The lower number means they have a lower priority for risk. Okay. Okay, so based on this assessment, we can determine the risk level to assess whether this risk level is acceptable or not. Okay, and the project owner or the project participant can determine their own criteria for acceptable risk level, but by recommendation of the TOSHA, they suggest the risk classified as moderate or high are considered as acceptable. So let's follow this criteria. So you have to take or plan risk treatment measures for medium or high level risk event. Okay? Okay. So for unacceptable risk, appropriate risk mitigation measures should be implemented to minimize risk to the lowest feasible level. So after you plan your risk mitigation measures, they also suggest risk control hierarchy for planning risk mitigation measures. First, elimination is the first priority. Substitution is second one, but in Tosha's CIA guide, they call it reduce the risk. And then engineering control, administrative control. Finally, is personnel to be. But after you implement this measure, you have to re-evaluate the risk associated with this work item or this operation, whether the risk level has been reduced to the acceptable level. In our guide, the acceptable level is low risk, either 2 RPN equals 2 or 1. Okay? Okay, so let's finish it. So after you plan the risk response measure, you have to prepare summarize the risk response plan for the project. Okay, for each operation, especially the operation you have identified and as a high risk operation. For those high risk operations, you need to prepare a risk response plan using either elimination or substitution or engineering control or administrative control approach. Okay? And then the designer and contractor should also supervise. They has to establish a supervision or review mechanism to make sure the effective implementation of CIA. Okay, so the major part is the first 3, 4. Okay, the major part for CIA is from work breakdown structure, then to risk assessment, then to risk evaluation, and determine the acceptable level of risk and plan the risk response and plan the risk response plan. That's the major part. Okay, and then the guide also talk about the supervision and review guideline for the CIA, both for the designer and the contractor. So for supervision and the review, they have to both the designer and the contractor has to establish an organization for risk management system. So the CIA team has to perform this function. Also for communication and consultation means that this supervision, this mechanism should be upgraded continually to consult and communicate with the stakeholder and continue the CIA periodically to improve the risk management performance. Okay. Okay, and this regulation should be established for forms, records, audit, and verification. And in Taiwan, we all follow Tosha's technical guide. They provide forms, record, and how to audit and how to verify your CIA implementation. Okay. And finally, they have to document everything you did for CIA, including work breakdown, risk identification, risk analysis, risk assessment, and risk responses. And these are actually the documents to be reviewed and to be verified by the mechanism we just mentioned. Okay? Okay, so this is the CIA form for risk analysis. This is a work breakdown structure from sub-project to first level, to second level, to operation, and the associated risk and risk analysis and risk responses are planned here. This is the simplified version for small project, and this is standard project form for general project with a contract price higher than 50 million NT dollars. Okay, so that's all for the CIA